Greetings, I'm Dev the Developer. This lesson is about recursion, a method that calls itself. That sounds kind of like it should be illegal, and honestly, the first time you see it, it kind of feels that way. But by the end of this lesson, the structure will make complete sense and you'll see why some problems are just naturally easier to write this way. Some problems are naturally self-similar. They're defined in terms of a smaller version of themselves. Recursion is how we write code that mirrors that structure. A method that solves a problem by calling itself on a smaller piece of it, until the piece is small enough to just answer directly. Here's a real-world version of that idea. Imagine you're looking up a word in a dictionary. You find the definition, but it uses another word you don't know. So you look that one up. Its definition uses yet another unfamiliar word. You keep going until you hit a word you already know, and then you stop, and you unwind back through all of the lookups. That's the shape of recursion. Keep going deeper until you hit something you can answer directly, then come back up. Every recursive method must have exactly two parts. Both are required. If either one is missing, the method is broken. The first is the base case. This is the condition where the method stops calling itself and returns a direct answer. It's the word you already know in the dictionary analogy. No more lookups needed. The second is the recursive case. This is where the method calls itself with a smaller or simpler version of the problem. And the keyword there is smaller. Every recursive call must move you closer to the base case. If it doesn't, you never stop. A method with no base call will call itself until the program runs out of memory. That's called a Stack Overflow. Not the website. The runtime crashes your program. So anytime you write a recursive method, before you do anything else, ask yourself, does this have a base case? And will every recursive call eventually reach it? Let's write something concrete, a countdown. Given a number, print that number, then count down to 0. With a loop, that's easy, but I want you to see how to think about it recursively, because that thinking is the skill. Recursive thinking goes like this. What is the smallest version of this problem I can answer directly? If n is less than 0, there's nothing to print. That's the base case. What about the bigger version? Printing a countdown from n is the same as printing n, then printing a countdown from n minus 1. That's the recursive case. Let's trace through this. Countdown 5 prints 5, then calls countdown 4. That prints 4, then calls countdown 3. This continues until countdown 0 prints 0 and calls countdown -1. That hits the base case and returns. And each previous call returns 2, unwinding back up through the chain. Here's the thing I want you to sit with. The method doesn't try to do everything at once. It does one thing, prints its number, and trusts that the smaller version of itself will handle the rest. That trust is the key to thinking recursively. The most commonly used example for recursion is factorial. The factorial of a number, n, written as n with an exclamation mark after it, is the product of every integer from 1 up to n. So 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. The recursive definition is n factorial equals n times the factorial of n minus 1. And 0 factorial equals 1. That last part is the base case defined by our convention. Factorial 5 is 5 times factorial 4. Factorial 4 is 4 times factorial 3. This unwinds all the way down to factorial 0, which just returns 1. Then each multiplication resolves all the way back up 1, 2, 6, 24, 120. The method doesn't know the final answer when it starts. It just knows it's one job, and it trusts that the smaller version of itself does the rest. Recursion has a reputation for being a bit difficult to understand, and I think that's fair for about the first hour. The reason is that your brain wants to trace through every single call at once, and you just can't hold all of that in your head at the same time. The trick is to stop trying to simulate the whole chain. Focus on two things only. Does the base case return a direct answer? Does the recursive call make the problem strictly smaller? If both of those are true, the method works. You don't need to trace it all the way through to trust it. Once you stop trying to follow every step and start trusting the structure, this stops being scary, and then it becomes one of those things you reach for naturally. The structure is always the same. A base case that stops the chain, and a recursive case that makes the problem smaller. Every recursive method you'll ever write has those two things. Go build some. Write the countdown, write the factorial, then try something of your own. Trace through until you can see why it works. Don't just watch it. Do it.